Hello, my dear students. As you know that we have just completed the chapter of circular motion, here are few questions from the past papers, right? Okay, these are some latest questions from 2023 and 2024. So attempt them very carefully, right? So the first question is define radian. You all know that radian is an angle formed by an arc at the center of circle such that arc length is equal to radius of circle, right? What is the equation of arc length? Arc length S equals r theta. ठीक है, जब ये एंगल 1 रेडियन होगा उस वक्त आर्क लेंथ विल बी इक्वल टू द रेडियस ऑफ सर्कल. सो यू विल राइट रेडियन इज एन एंगल formed by an arc or subtended by an arc at the center of circle such that arc length is equal to the radius of circle. Arc length is equal to the radius of circle. Right? Moving on to the next question. Next part, in fact, and this is a circular metal disc spins horizontally. Right? There is a disc. हमने इसको turntable के reference में पढ़ा था. Right? You remember that turntable पे हर point पर angular velocity was constant, irrespective of radius, because every point covers same angle in same time, so omega was constant, right? Circular metal disc spins horizontally about vertical axis as shown in figure 1.1. So आपको एक horizontal plate का horizontal disc का top view show किया, right? A piece of modeling clay is attached to a disc, right? Modeling clay लिया और उसको disc के साथ attach किया होगा. For the instant when the piece of modeling clay is in the position as shown in figure 1.1, you have to draw an arrow labeled V showing the direction of velocity of the modeling clay. But जो हर point पर velocity जो होती है वो tangential to the circle होती है. तो इस point पर जो object की velocity है, modeling clay की velocity है, this will form a tangent to a circle. So this is the direction of its velocity. And you will label this arrow V, right? In the next part, you have to draw an arrow labeled A showing the direction of acceleration of modeling clay. You all know that centripetal acceleration and centripetal force always point towards the center of circle. So this is the direction of centripetal acceleration or centripetal force. Here you have to label the direction of centripetal acceleration. So this is the direction of instantaneous velocity and this is the direction of acceleration, right? So what is the angle between them? The angle between them is 90 degree, लेकिन आपने इसको exam में mention नहीं करना, right? Moving on to the next part. The metal disc in figure 1.1 has radius of 9.3. याद रखिएगा ये metal disc का radius है, modeling clay का radius थोड़ा सा different है, right? The center of gravity of modeling clay is 1.2 centimeter from the rim of the disc and moves with a speed of 0.68 meters per second. So what will be the radius? आप radius find कर लें. आप लिखेंगे radius of modeling clay. जिस orbit में वो move कर रही है, जिस path पे move कर रही है, उस path का radius will be 9.3 minus 1.2 centimeters. And this will be 8.1 centimeters. याद रहे कि दिस इज रेडियस, राइट? इस सेंटर से लेके मॉडलिंग क्ले तक का डिस्टेंस, दिस डिस्टेंस इज रेडियस, राइट? ओके, यू हैव टू फाइंड द एंगुलर वेलोसिटी. यू हैव रेडियस, you also have linear velocity which is 0.68. Which formula you will use here? You will use V equals R omega. Linear velocity is equal to radius multiplied by angular velocity. So you will write V equals R omega. Right? Angular velocity, angular speed is equal to V divided by radius. Velocity is 0.68, radius is 8.1, and you need to convert it in meters. So you will divide it further by 100, right? So 0.68 divided by 8.1 by 100, your answer is 8.395. In 3 significant figure, this value is 8.40 radians per second. 8.40 radians per second. Right? बहुत आसान part था. Let's move on. In the next part, you have to calculate the acceleration A of the center of gravity of modeling clay. Now you know that center of gravity of the modeling clay is present at the radius of 8.1 centimeters and its angular velocity is 8.40 radians per second. ठीक है, आप डिस्टेंस को रेडियस को मीटर्स में तो कन्वर्ट करेंगे ही. अब मुझे ये बताइए which formula of acceleration you will use. There are two formulas of centripetal acceleration. One is r omega square and the other one is v square divided by r. So here you have the information of radius and angular velocity. You will use this formula. Acceleration is equal to r omega square. So radius is 8.1 divided by 100 multiplied by omega, which is 8.4 square, right? So 8.1 divided by 100 multiplied by 8.4 square. Your answer is 5.72 meters per second square. 5.72 meters per second square. Right? Moving on. A second piece of modeling clay is attached to a disc as shown in position 1.2. जी बच्चों, ये first piece है. This is the first piece. अब second piece जो connect किया है वो larger in size है और उसका distance from the center is comparatively lesser. ठीक है? This is the second piece ना. इसका distance from the center is comparatively lesser. Right? By placing a tick in each row, complete the table 1.1 to show how the quantities indicated compared to the two pieces of modeling clay. The first one is angular speed. आपको मैंने बड़ी डिटेल में पढ़ाया है बच्चों. Angular speed is constant everywhere in a turning system because each and every point covers same angle in same time. Angular speed is equal to theta over t, angular displacement by time. हर पॉइंट के लिए थीटा भी सेम, हर पॉइंट के लिए टाइम भी सेम. सो एवरी पॉइंट हैज सेम एंगुलर स्पीड irrespective of radius. So both of the pieces, for both of the pieces, angular speed is same. So you will place tick here. Same for both pieces, right? In the next part, he's asking you for the linear speed. What is the formula of linear speed? In fact, हमने formula को use भी किया है, V equals R omega, right? So for constant angular speed, linear speed is proportional to radius. Now, which one has greater radius? First piece has greater radius, so that's why it will have greater linear speed. So, linear speed is greater for first piece. So, less for the second piece than the first piece. The right answer is this. And the last one is acceleration, right? The formula of acceleration is equal to r omega square. Right? For both of the pieces, omega is constant. So once again, acceleration is proportional to radius. Now once again, radius is greater for first piece because that is present at the edge. Right? So first piece के लिए centripetal acceleration भी ज़्यादा है. So less for the second piece than first piece. The right answer is this one. Right? So this was very easy question. जो कुछ भी आपको बताया है as it is apply हो रहा था, there is nothing new. So we have completed this question for 10 marks. And this was question about horizontal circle. Let's do one question about vertical circle. Right? Define radian. Once again we have written the definition of radian और याद रहे कि एग्जाम में सबसे frequent definition जो है वो radian की ही आती है. So you will write radian is an angle formed by an arc. Angle formed by an arc at the center of circle, such that arc length is equal to the radius of circle. Right? Moving on to the next part. The minute hand of clock revolves at constant angular speed. Now you know which is the minute hand, the one which shows minutes. And it completes its one revolution in how much time? In 1 minute? No. Minute hand completes its one revolution in 1 hour. Right? 1 minute में तो seconds hand अपना एक motion, एक circle complete करता है, right? So, a minute hand of clock revolves at constant angular speed around the face of the clock, completing one revolution. देखिए वही बात, it complete one revolution in 1 hour. Right? A small piece of modeling clay, by chance इस question में भी modeling clay involved है, is attached to the hand with its center of gravity at distance L from the fixed end of the hand, right? So बच्चों इस केस में इस clay के लिए this L is its radius, right? As shown in figure 1.1. The direction of revolution, definitely clock है तो वो clockwise direction में जाएगी. This arrow is showing you the clockwise direction of this clock, right? Okay. Calculate the angular velocity or angular speed for the minute. बच्चों मिनट्स हैंड अपना एक कंप्लीट रेवोल्यूशन कंप्लीट करती है 1 आवर में, एंड दिस 1 आवर इन सेकंड्स इज 3600 seconds, right? So you have to write the expression for angular speed, omega equals 2 pi over capital T. 2 pi divided by time, which is 3600, right? So 2 pi divided by 3600, your answer is 1.75 multiplied by 10 raised to power minus 3. 1.75 multiplied by 10 raised to power minus 3, and the unit is radians per second, right? 1.75 multiplied by 10 raised to power minus 3. Okay, the next one. During a time interval of 1400 seconds, the center of gravity of the piece of modeling clay in figure 1.1 moves through a total distance of 0.44 meters. Calculate the angle. ठीक है बच्चों, आप लोगों ने यहाँ पर एंगल फाइंड करना है जो वो कवर करेगी in how much time? In the time of 1400 seconds. So simply you can use this formula of omega. Omega equals theta over given time t. ठीक है, you have the value of omega from the previous part. You are given with the value of time as well, right? Simply आप लोगों ने यहाँ से theta की value find out करनी है. So let's make theta subject of the formula. So theta is equal to omega multiplied by t. Omega is 1.75 times 10 raised to power minus 3, and the given time is 1400 seconds, right? Okay. So 1.75 multiplied by 10 raised to power minus 3 multiplied by 1400 seconds, your value is exactly 2.45. So the angle will be 2.45 radians. Right? 2.45 radians. Determine length L. बच्चों previous part से आपको ये पता चल गया कि जो टोटल डिस्टेंस कवर करेगा मिनट हैंड इस तरह की डायरेक्शन में, वो एक सर्कुलर पाथ में कवर करेगा. सो इट विल बी मोर और लेस लाइक एन आर्क. ठीक है, तो वो आर्क फॉर्म होगी. मैं आपके सामने यहां पर एक ड्राइंग बनाता हूं. दिस इज इट्स रेडियस एंड दिस रेडियस इज इक्वल टू एल. जो भी एंगल कवर होगा, मैं यहां पर रफ बना रहा हूं. डेफिनेटली ये ऑब्ट्यूस एंगल होगा, लेकिन मैं यहां पर ये सिंपली ये वाला एंगल ड्रॉ कर. दिस इज ऑल्सो इक्वल टू एल. द एंगल कवर्ड इज 2.45 radians. ठीक है, यू हैव दिस डिस्टेंस एज वेल. उसने कहा है दिस टोटल डिस्टेंस कवर्ड इज 0.44 meters, and you have to find the value of L, which is marking the radius in this case. So how you will find this radius? Simply by applying the equation of arc length, which is S equals R theta. ठीक है. Total distance given as 0.44. You have to find the value of radius is represented by symbol capital L and theta is 2.45. Capital L is equal to 0.44 divided by 2.45 and your answer is 0.179 meters. 0.179 will be rounded off to 0.180 meters. So your answer is 0.18 meters. Now in the next part, calculate the magnitude of centripetal acceleration for the piece of modeling. You have two formulas. Centripetal acceleration is equal to v square over r. Centripetal acceleration is equal to r omega square. ठीक है, यहाँ पर आपके पास बच्चों रेडियस की भी इंफॉर्मेशन है और एंगुलर स्पीड की भी इंफॉर्मेशन है. सो आई विल प्रेफर दिस सेकंड फॉर्मूला, राइट. Centripetal acceleration is equal to r omega square. So radius is length L, which is 0.18, and omega in this case is 1.75 multiplied by 10 raised to power minus 3, and you have to square this value as well, right? 0.18 multiplied by 1.75 multiplied by 10 raised to power minus 3 whole square. Your answer is 5.51 multiplied by 10 raised to power minus 7 meters per second square. 5.51 multiplied by 10 raised to power minus 7 meters per second square. Let's move on to the next part D. Use your answer in C3 to explain why the variation with time of the magnitude of force exerted by minute hand on the piece of modeling clay is negligible as the minute hand undergoes full revolution, right? So why this force is negligible? So बच्चों याद रखिएगा, the magnitude of centripetal force is very small because centripetal acceleration की value बहुत कम आ रही है, right? So centripetal force is much smaller than its weight. Why? Centripetal force is equal to m times centripetal acceleration. ठीक है, mass बहुत कम है, इस वजह से centripetal acceleration भी बहुत कम होगी. That's why the force exerted is very small because this resultant force is much smaller than the weight of modeling clay, right? So you will write that the resultant force is very small. That's why the magnitude of force exerted by the minute hand on the piece of modeling clay will be negligible. ठीक है? So the baseline is this centripetal force or the resultant force is much smaller than the weight of modeling clay, right? So in this video we have done 2 questions, right? You have to do more questions from the past paper. In this video मैंने इसमें सिर्फ 2 questions cover किए. You can practice some more from the past papers and we will do some in the past paper sessions. So stay tuned for the next upcoming videos. Do subscribe Slate. Thank you.